Hello, my name is Ryan Hicks. I have roughly 8 years of experience in IT with an undergrad from Louisiana Tech and 4 years in the Army as a military intelligence systems maintainer. I chose to add data analytics to my toolbox in order to become more of an asset in my current job. I chose Savvy Coders to be this avenue for new learning. And for the capstone for Savvy, I'm using Powerball predictions. So this year we saw a record high in Powerball jackpot, which piqued my interest in finding out if you could actually improve your odds. So what better way to test out these new skills learned through data analytics course? I also wanted a fun and intriguing capstone. My plan is to take the last 10 years of drawing data and apply probability equations to find the frequency of each number with the hope that this will produce a list of most likely numbers to be drawn. I used Jupyter Notebooks, Excel, and Python during my capstone, but also taught SQLite and Agile through Savvy Coders. So the ultimate question is, can data analytics predict Powerball using empirical data? Some other questions I also had were, what are the top five biggest jackpots, with this year being a little over $2 billion, and then kind of subsequently going down over the years. The probability of actually winning the Powerball is 1 in 292 million. I'll explain how that number has actually come about. But if you wanted to make sure you were 100% and win the Powerball, you have to spend over $584 million at $2 a ticket to get every possible combination. So in order to get that 1 in 292 million, you use this equation down below, which is n factorial over r factorial times n minus r factorial. So n is the numbers that are possible to pull. And then r is the actual numbers that are pulled. Factorial just means the product of all positive integers less than or equal to a given positive integer denoted by the integer expression. Basically, you just take that number and multiply it until it gets down to 1. Another question is, so what does that equation actually look like? So for the white balls, you have 69. So you have a pool of 69 balls, and then you pull 5, and then you multiply that by the 69 minus 5, which gives you just over 11 million. For the Powerball, it's 26, which just gives you 26. And then you combine those two probabilities, and that gives you the 1 in 292 million. Another question is, what if you're not necessarily concentrating on getting all 5 balls with the white ball? We saw from the last slide, or from the last question, that it's 1 in 11 million for just the white balls, and it's 1 in 26 for just the Powerball. To predict to find the probability of the other ones, we introduce another variable called K, and that's the number that you actually chose correctly, and which is stated in the formula just below. But for 4 white balls and a Powerball, it's 1 in 913,000. For just the 4 white balls, it's 1 in 36,000. For just 3 white balls and a Powerball, it's 1 in 14,000, and for just 3 white balls, it's 1 in 579. So some of the methods that I used mostly Python to clean up this data. I'll show you the original data set in just a second, but I'm going to walk you through some of my Python codes and let you know how I got to where I'm at. So here is my Jupyter Notebook where I use Python. Up here at the top, you can see where I imported the data set from Powerball. One of my biggest hurdles was that in this data set, it used different delimiters. So it used commas and spaces and slashes. In order to get around that, I used indexing. So I was able to take just the draw dates. I only started with 2 columns, just the draw dates and numbers, and separate them into months, days, years, and then each number into its own column. And then I'll drop what I didn't need. I later came down and recombined the year, month, and day into its own date form, because through a little bit of research, I found out that in 2015, the actual Powerball game changed and went from 59 white balls to 69 white balls, and from 35 Powerballs to 26 Powerballs, which in this right here, you can see I eliminated all prior drawings from 2015 of October. This portion here is where I am taking the individual white balls, the num columns in this status, and I am finding the frequency of each number in those columns. So it's taking all the ones and combining them, all the twos and combining them all the way down to 69, and that way I can get a frequency of how many times those numbers actually have occurred. And then I take that frequency and then right here, and then I divide that by the 809. So 809 is how many drawings are left after I applied that code to eliminate anything prior to 2015. And then down here, multiply it by 100 to get percentage, and concatenated and made those all into one data frame, and then save. This portion here, to add a little bit more complexity to my capstone, I wanted to find the two combos and three combos, which one occurred the most for each set. So what set of two numbers occurred the most and what set of three numbers occurred the most. And then this scripting, this is how I did that. So again, I took those num columns and combined them to create just the white ball numbers. And then I took that and then I created the three number combos using Lambda and string from Python and kept going. Down here where it says separated three combos is actually where I made it into different lists. Well, this up here is where I made it into different lists. So it takes all 5 balls and it finds all 3 combinations for the set of 5. Same thing with 2. And then down here it takes those lists and it separates them by commas, and then it puts them in their own row as well. And that way I can get a count of each one of those. And then the same thing occurs for the 2. And then that was saved as well. So as promised, this is how the original data set looked. It was just the draw date and all 6 numbers, including the Powerball. So your five balls and then your Powerball all in the same one. So it can't really find any frequencies in that because it combines all of them together. And that was what the scripting was doing. It was separating everything and making it where it's easier to draw out conclusions. So this next one is the actual white ball frequency. So using this, we can actually see that there is something to some balls falling more often than others. In this case, it is 61 and 32, which fell 77 times, and 809 times there were drawings. And then for 26, it only fell 43 times. And then for the probability of this, for 61 and 32 is 9.5%. That those balls are actually going to fall. So, which isn't the greatest, but for 26, it's only 5 and a third. For Powerball numbers, it's 24 was the most drawn at 45, and 23 had 22 appearances in the 809, giving the probability that 24 will be drawn at 5.5%. So these are the 2 combo frequencies. This is actually a cut down version of what was actually produced. There was thousands of combinations. So in order to make it fit here, I only limited it down to 8. So the top frequency is 11, which, as you can see over here, is 8 and 27, 7, 15, and 32 and 58. In the last 10 drawings since this data set was captured, these numbers haven't appeared together. And the same goes for 3 combos. This one, again, there was a lot of combinations with a varying from 0 to 4. So I just eliminated everything other than the 3 to 4. Which again, there's 3 that are at the top. 715, which is from our 2 combo with an added of 36. 12, 20, and 21, and 1, 3, and 13. Again, in the last 10 drawings since this data was captured, these 3 combos haven't been seen. So my conclusion from the chart shown with the highest probability for white balls, 61, 32, 63, 21, 69, and a Powerball of 24 are the most probable number. But since this data was captured December 3rd, we have 10 drawings, and the most recent, or the one most recent following this data set was 34, 45, 47, 54, 55 with a Powerball of 14. Out of those 10 drawings that happened since this data was captured, only 61 has appeared 3 times. So that's not very good for data analytics predicting the Powerball. Same thing as I said earlier, the 2 balls, nothing occurred in the last 10 drawings. So my conclusion is that this time I am unable to predict the outcome of the Powerball. Future steps are to add a random data distribution loop, which allows for the probability that I have found here to be added into the random choice. So you're basically letting the computer kind of give its random numbers, and then hopefully that computer and the random numbers kind of match together. So that would be my end result in there. I just wanted to thank Savvy Coders and my cohort members and the excellent instructors and TAs that helped me through this new skills journey. Also, Agile was a big product of helping me plan and keep my project on track. So thank you.